Hi, Paul Beckwith again. So, global to local. Abrupt climate change, global changes, Arctic changes causing global changes in air circulation and ocean circulation. How does this affect local scale? The impacts to anywhere and any project and environmental impact studies for these projects. We need to do things in a different way. We can't do things the way we've done up to now. We have to be smarter. So if you look at the climate history of, which is basically temperature and precipitation over the last century in any particular place, historical averages and trends are often used as a basis for expected future changes. There can be large errors and uncertainties in this. Rapid climate change is changing the statistics of climate and thus weather events and thus recurrence intervals. Like a 1 in 100 years doesn't mean 1 in 100 years. It doesn't happen every 100 years now. It could happen every 10 years or every 5 years. The variability jumps, super warm, super cold, huge rainfall, drought, has increased across most timescales. If you look on decadal or year-to-year or even seasonal or monthly or weekly timescales, the variability is jumping up. Weather whiplashing applies. A city or region can have record high temperatures one week, record low temperatures the next week, and swing back to record high. This is because the jet stream is crossing and you move from being in the trough to being in the crest to being in the trough, for example. This risk of weather wilding is dependent on the location relative to the jet stream waves. For example, in North America, summer in March event. 2012, we had a heat wave in North America. First week of March was normal cold temperatures in Canada. Second week, 15 degrees Celsius warmer than normal in Ontario. Then third, fourth week, killing frost below zero. Killed all the buds that came out in the warm period. They didn't know what was going on, poor little buds. And it caused 100 million damage to Ontario's apple crops. Okay, just that effect. I'm talking about buds of apples, right? Not other, anyway, yeah. So here is the heat wave in 2012, March 8th to the 15th. Look at the temperature anomalies, 15 degrees Celsius, warmer than normal over all these regions. Okay, the duration, the size, and the intensity of this heat wave are simply off scale. This ranks as one of North America's most extraordinary weather events in recorded history, according to Wonderground in 2012, after it happened. The growing season started 5 weeks early. Early snowpack caused low river flows in the summer, and the stage was set for summer heat and droughts. So it not just only affects this time period, it carries through the rest of the year. Climate projections for local areas, anywhere, any project, are based on downscaling the global circulation models, these GCMs, which are just cranking through with supercomputers on physics formulas, knowing the state of the Earth at one time, the state of the weather and climate weather at one time, and trying to run it through on the computer. Now, you know, people spend loads of money and, you know, they invest all kinds of energy into these models. You know, they forget to look out the window. The models quite often tell them things that just don't jive with reality. For example, the models on sea ice decline. Okay, they mirror a slowly varying linear climate system. They don't normally pick up the abrupt changes, the jumps. It's very risky to rely on these models when we're experiencing rapid changes that have not been described or occurred earlier. They're not incorporated in the models. How can they be? We can only put in the program what we understand. The hydroclimate studies, you know, are very important for lake levels, stream flows, water temperatures. Manitoba has a lot of hydro power generation. When there's drought, water levels are down, power drops a lot. The province has to import power from elsewhere. Okay, we have data on the last century and projections from the models, but there's a lot more variability going on. So these studies have to be taken as being less reliable. these probabilities are based on climate statistics are based on a stable climate. 1 in a 100-year or 1 in a 1,000-year events need to be evaluated. They're no longer valid. They're useful to do these models, to do these studies, but we have to add in, we have to say, okay, does this make sense in the existing climate? I mean, maybe just weighting the recent behavior over the nearest decade makes a lot more sense than, weighting it back over a much longer time period. It affects water temperatures of lakes. Like Lake Winnipeg is a large freshwater lake. And the water temperature is important. During heat waves with extended droughts, there's annual evaporation can remove 20% of the inflow into the lake. So the lake volume decreases, water levels drop, the water's warmer, there's stratification, less vertical mixing. You can get eutrophication, lots of blue-green algae blooms growing, similar to what happened on Lake Erie in the summer of 2014, which took away the water supply for a major city. Less lake volume, less hydropower, less power for, this is a transmission line, electrical supply in this case, okay? The different rivers coming in, especially if they're glacially fed or drying up, declining levels. There's also a lot of the human elements, right? Because when you think about where this water, so as we get snowpack decreasing, it affects up to 70 million people in the American West. But think of the people in Asia, the billion plus people affected by the water. Okay, now there's also human issues. There's water access rights. So the sources in Alberta, 1 unit of water in Alberta from the snowpack melting goes into this river. Alberta gets half of that water. Saskatchewan gets half of the remainder, which is 25% of the input, and Manitoba gets less, gets the rest. So they get left holding the bag. If the source decreases and there's nothing left coming out, the river dries up basically. All these rivers of the world are affected by, they generally run long distances through multiple states and stuff. They can pit states against states. Civil wars have started on less. People have to drink. People have to drink and eat. And if they can't do those things, then they get really angry at all their neighbors that are eating and drinking while they can't. Okay, so it's a risk to people around the planet, not just in Manitoba. Okay, Himalayas, Andes, Rockies. You can do this type of study for wherever you are. Climate normals are from the 30-year period. If you do all your studies based on 1981 to 2010, well, a lot of climate change has already occurred in this period. So, why would you take this normal? That just doesn't make sense. You have to take earlier averages, or at least monitor, how, if you do everything with respect to this time period, how does it change if you go to the early, a decade earlier, a decade earlier, a decade earlier? Climate change has a huge impact on this number. So comparing things happening now to this average, that hides climate change in the previous decades. It doesn't seem to be kosher. Okay, if there's a wet cycle for the last 15 years or so, there's no expectation this will continue, right? Great for Manitoba Hydro and their power generation, but, we have this whiplashing. It could be record drought the next year, then record flood, then record drought. Huge variability. Now, if you're building infrastructure, in this case, it's a transmission line. So it's a power line. You build the power poles, the towers, and then you string conductor. Okay, so, in this industry, what are the cheapest towers are these huge ones. They're freestanding, they're lattice, so it's a whole bunch of triangles in the structure because engineers know that the triangle is the most stable. And you put multiple triangles together. Look at the bridge. Look at any structure made of, metal, made of beams, and you see, excuse me, you see these triangle structures. Okay. So these poles, if we're using technology of poles that are 100 years old, well, in my trip across Tornado Alley, I saw just about well, all and every design of power poles, because they get tired of replacing them every few years when a tornado comes through. So they figure out, hey, maybe we should build these things stronger and stronger. Maybe we'll save money, because it's not just money up front, it's money of operation. And if they're knocked down every few years, maybe you want to build some that are stronger, that are going to withstand a tornado unless it's directly overhead. So you also have stations and substations in this project, and if these things are inundated by floodwaters, that'll take out the power supply. You know, think of the rainfall in Calgary and the Toronto event in 2013, large regions of Ontario, Quebec, and BC. You know, flooding and electrical power doesn't mix too well. Tornadoes are always a risk to power line infrastructure, so we need the statistics of the storms. How are the tornadoes changing with climate change? Tornado Alley in the U.S. was where I went. Maybe in a few years I'll just need to drive out to Manitoba, Alberta, Saskatchewan to get to Tornado Alley. Maybe the Tornado Alley, as the jet streams are changing, as the regions where you have a clash of warm, humid air from the Gulf and cold air from the north, as there's less and less cold air from the north coming down, maybe it won't get so far. Maybe the clash of warm air will be in Canada. All the U.S. storm chasers will come up to Canada to do their tornado chasing. Is this possible? Sure, why not? I mean, stuff changes. These straight line winds are happening more often, and they're strong enough to damage transmission lines and power grids. Rapidly moving frontal system can extend over a large region. I showed the New Brunswick storm toppling power poles. Okay, ice storms. We had a big ice storm, you know, Quebec, Ontario in 1998. You need a very tight temperature range. If you know, around zero, that could happen more frequently with climate change, maybe as you start going through there, or maybe not. So the locations of freezing rain can shift, and that brings down structures. These heat waves are problematic to a power grid. You know, it can affect the source, of course. If you don't have cooling water to your nuclear plants because the river water temperatures are too high and the rivers are too low, then you have to shut down the plants. These power lines, when you heat them, of course, they'll expand like any other material. When they expand, they sag. They could droop down onto vegetation. Also, the conductivity decreases as the temperature increases. So the resistance of the conductor increases. There's ohmic heating. As the current, the power is I squared R. Power heats up, things heat up, and then they can go into runaway heating and just melt through. So the risks of fire are greatly increased. Also, the forests surrounding are dry and stress in heat waves, and when they burn, they can shut down the grid. Okay? Many other companies have an over-reliance on IPCC, Intergovernmental Panel on Climate Change, climate models. There's so many in these GCMs, as I said, and how good are they? They're not accounting for the changes that are happening right now. There's different climate atlases with norms and stuff, but the sea ice and snow cover, again, change those. Okay, we need to incorporate Arctic feedback effects and the rapidly abrupt climate change whenever we produce any infrastructure. So basically, the more extreme weather events, more windstorms, more derechos, we have to build better, more stronger, more resilient infrastructure. For example, don't use these latest standalone towers that are a century old design. Use guide towers, use streamlined pole towers that are in Europe and in Tornado Alley. They're shorter, there's more of them. So, you know, you don't have to keep replacing them. So here we go. Google climate change faster than expected. You find enormous stuff. Try climate change slower than expected, next to nothing. Climate change as expected, squat. So the expectation is wrong. Everything's happening faster than expected. This means we need to obviously change the expectation and change everything that we do. Like this would be a joke, really, if the consequences were not so severe to humanity. So I think I'll finish up here. Thanks for listening.